We're going to start with the cardiac cycle, then we'll finish with the heart valves. So, the cardiac cycle is a series of pressure changes that takes place within the heart. Cardiac cycle event can be divided into diastole and systole. Diastole represents ventricular filling and systole represents ventricular contraction. So we are going to use this diagram here, this heart diagram, so that to help us with the illustration. These are the ventricles, the lower parts of the heart, the lower part of the heart, as in the lower chambers are the ventricles, then the upper chambers, they are the atrium. So we have the right ventricle, we also have the left ventricle. So ventricular diastole represents ventricular filling. When there's filling of blood in the ventricles, that's what we mean by diastole. And systole represents ventricular contraction. So in this of our diagram here, if just follow my cursor so that you can understand what I'm talking about. In this of our diagram here, this is the septum, and here we have the ventricular wall. So when the ventricular wall contracts, it increases pressure within the ventricles, making the blood, pushing the blood out into the blood vessels. So that's what we mean by systole. Systole and diastole occurs both in the right and the left heart. So this in this of our diagram, we have the right heart, this one, this the right heart, then this the left heart. This other side is the left heart. So the septum divide the heart into the right heart and the left heart. So we have the right heart has the right atrium and the left ventricle, and the left heart has the left atrium and the left ventricle. So in each sides of the heart, we have diastole and systole. There's diastole and systole in the right heart. We also have diastole and systole in the left heart. Diastole begins with the closing of the aortic valve and ends with the closing of the mitral valve. To get a better understanding, let's go to the next slide that has the diagram of the valves. So this 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 is the diagram I'm talking about. So we are being told this diastole starts with the closing of the aortic valve. This is the aortic valve right here. This our aortic valve, and ends with the closing of the mitral valve. Here is the mitral valve. In a simple way, you can say it's just AM. Like that's how you can describe the systole of the left heart. You can describe the diastole of the left heart. Then let's go back to the previous slide. Here we are also told that diastole begins with the closing of the pulmonic and the tricuspid valve. If we come to the right heart, here is our pulmonic valve. Here it is the pulmonic valve. Then here is the tricuspid valve. So it starts with the opening, with the closing of the pulmonic, and ends with the closing of the. It starts with the closing of the tricuspid valve and ends with the closing of the pulmonic valve. This our pulmonic valve right here, and this our tricuspid valve. So, so we are told that the period encompasses the ventricular relaxation and filling. So, systole begins when the mitral valve or tricuspid closes and concludes with the closure of the aortic valve. So now we are going to take systole, and systole is can I say it's the other way round. So here we find that it begins when the mitral valve closes. Well, here is our mitral valve. When it closes, that's when the systole begin, and it ends when the aortic valve closes. And here is our aortic valve. So it's the other way round. Then if we come to the right heart, we find that systole begins with the closure of the tricuspid. Here is our tricuspid, and ends with the closure of the pulmonic valve, the pulmonary valve. Here it is. So these stages of cardiac cycle represents the ventricular contraction forcing blood into the arteries. So we find that you see like here the valves that leave the heart, we have the valves that aid in the passage of blood from the chambers into the blood vessels. We find them, they form like an inverted V. Yeah, let's say it's an inverted V, because if you take the pulmonary valve, it's an inverted V. It faces upward. It's something like this. And if we come to the aortic valve, it's also kind of an inverted V. It faces upward. So when there's increase in pressure down here in the ventricles, when the ventricular walls contract, there will be an increase in pressure. The increase in pressure will force the blood to open the valve. That's the pulmonic valve and the aortic valve, enabling the blood to get into the blood vessels. And the same increase in pressure in the pulmonary valve right here will force the tricuspid and the mitral valve to open. You see, they face their V, they form a V shape. So when there's an increase in pressure, let's assume this where my thumb is pointing, that's the atrium. So when there's increase in pressure here in the atrium, it will force the valve to open. It will open towards the ventricle and allowing the blood to get into the ventricle. That's in the tricuspid valve and the mitral valve. That's how they'll behave when there's increase in when there's contraction in the atrium, the left atrium and the right atrium. So this status of cardiac cycle represents ventricular contraction, forcing the blood into the arteries. When a ventricle contracts, the pressure within the ventricles will become greater than the adjacent blood vessels, and the valves will allow the blood out. That's what I was just explaining before with my fingers. When the ventricles contract here the ventricular walls, we have the right ventricle here, we have the left ventricle here. When these walls contract, when they contract, they'll create a pressure here inside here. So they will force the blood to look for a way of exit, so that so when the increase in pressure, when there's high pressure, the blood will force through the valves. That's the pulmonary valve and the aortic valve and into the blood vessels. So when the ventricle contracts, the pressure within the ventricles will become greater than the adjacent blood vessels, and the valves will allow the blood out. So we find that atrial systole, systole is the contraction. So when the arteries contract, when the walls of the arteries contract, let's go back to our previous diagram. When the walls, these are the walls of the arteries, they are here. When the walls of the atrium contract, here is the atrium. So I find that contraction of the atrial systole is the contraction of the atria, and we find that 70% of atrial emptying is passive. It doesn't need any contraction, and then contraction of the atria completely empties the atria of the remaining volume. So 70% of the blood in the atria, it it empties by itself passively without any increase in pressure or anything. Then the remaining blood that will not have penetrated through the valves into the ventricles, this when the contraction will help the blood to will increase the pressure within the atria. So let's come back to our diagram here. So the remaining 30% that's in here, this the atrium, the right atrium here, and this our left atrium. So 70% of the blood from here and here will just flow passively into the ventricles. Then the remaining 30% will pass the valves by when there's increase in pressure, and that increase in pressure will come from the contraction of the walls of the atrium. These are the walls here. These are the walls of the atrium. When they contract, they'll increase in pressure right in here, and it will force the blood to open these valves. Same to this side, it will force the blood to open this valve into the ventricles. So let's come back here. So we find that the pressure within the atria opens the atrioventricular valve. From just the name atrioventricular valve, it's the valve that's in between the atrium and the ventricles. That is the mitral and the tricuspid. Here is our atrioventricular valve. Here is one tricuspid. It's it's the valve between the atrium and the ventricle is our atrioventricular valve one, and here is our another. Here is the other atrioventricular valve two right here. You can follow my cursor and see what I'm talking about. This is the second one. So let's go back to the slide. Ventricular systole, that's the contraction of the ventricles. Then complete cardiac systole is the relaxation of the atria and the ventricles. So now let's finish with the heart valves. It's going to be simple because I've tried explaining it in the previous slides. The heart valves open and closes depending on the pressure difference in the cardiac chamber. When there's high pressure in the atrium, the right atrium. Let's go back to our diagram. When there's high pressure within the atrium, when there's high pressure in the right atrium and the left atrium, it will force the valves open. It will force this valve open to allow blood into the ventricles. Then let's go back here. AV, atrioventricular valve. The AV stands for the atrioventricular. The atrioventricular valve opens during atrial filling and systole due to the high pressures in the atria as compared to the ventricles. So they will open these valves, the atrioventricular valves. That's the tricuspid and the mitral valve. They will open due to the high pressures within the atria and allow blood into the ventricles. So the atrioventricular valve open during atrial filling and systole due to high pressures of the atria as compared to the ventricles. When the ventricle contracts, there is increased pressure in the ventricles, forcing the atrioventricular valves to clamp shut. So let's go back to our diagram. So when there's a lot of pressure here, we find that the atrioventricular, that's the tricuspid valve, this one right here, you can follow my cursor, and the mitral valve, they point down this way. They form something like this. So when there's increase in pressure, they will shut. So, like it will form something. It will be like closing. It will be closing. And when there's an increase in pressure in the atria, it will like open. You see, that's how it will be moving. So that will happen when there's increase in pressure in the atrium, in the right atrium and the left atrium. So the pulmonary and aortic valves open to allow blood into the blood vessels. Here's what I was talking about again. The pulmonary, here is the pulmonary valve, and here is the aortic valve. These two valves will be facing the upper part. So when there's increase in pressure, they'll open up. They will open to allow blood outside into the blood vessels. That's how they'll behave. So what else? We find that when the ventricles relax, the pressure within falls and the pulmonic and the aortic clamp shut and the AV valves open. So that's what I have for today's presentation. Let's meet in my next video. If you found this video to be helpful, don't forget to like, subscribe, and if you feel like there's something we need to add, just drop it in the notification into the, just make sure you don't, you just drop it in the comment section.